Okay guys, let's take a look at today's lesson. Today's lesson is on linear combination property. This is one property, the linear combination property, that's going to be helpful to us. In this particular instance, it's going to allow us to take cosine and sine and combine them into one, basically one trig function. So that's what we're going to be working on today. So let's talk about, first of all, what happens when we add two sinusoids. What happens? If they are like this, like the 3 sine, so let's look down here, this f of x right here is in red. So 3 sine is graphed in red, and 4 sine is in blue. If we add those together, then in this case, the sum, we add the two amplitudes, the 3 and the 4, and that gives us our green graph of the 7. That technique only works when the sinusoids are in phase. In other words, if they have the exact same locations for the highs and the lows. So if that happens, which is quite rare, I would say, right? You could do that. You would basically just, the period would be the same, the amplitude would be the sum of those. That's really not what we are going to be working on today. I'm talking about this so that you can understand how the functions work together when we add them. So if they are in phase, it's simply adding the amplitudes together, and that gives us our, combined the sum graph. What we're actually going to be working on are sine and cosine. We're going to be adding sine and cosine and converting them to this form. So if we add two sinusoids that are not in phase, like for example these right over here, the amplitude is actually less than the sum of the two amplitudes. So if you look, we have 3 cosine is in red, that's f of x right here. We have 4 sine is in blue, and then the sum of those two is in green. So see, it's not, a perfect little symmetrical picture like this. It's a little bit more messy. Okay, so these are not in phase. These don't have the same locations for highs and lows. In that instance, what we can do with problems like this is we can combine them. But this is key right here. They have to have equal periods. If they don't have equal periods, we can't do this. Okay, we can't do this if they don't have equal periods. That is, has to take place. That's critical. So let's look at the formula. So what do? We have b cosine plus c sine equals a cosine x minus d. Now I want to point a couple of things out. Your sine and cosine, they could write them in the problem reversed. They might try to do that to trick us, right? They might write the sine first. We need to understand that b goes with the cosine regardless of which order it's in, and c goes with the sine regardless of which order it's in. Whether the sine comes first or last, it still has the c in front of it. When this is the case, we can rewrite it as a cosine x plus d, or theta, whichever variable that we're using. So let's look and see, how do we find a and d? How does that work? So a is simply the square root of b squared plus c squared. That's all it is. It's like the hypotenuse of the triangle. And we're going to look at it more specifically. So a, pretty straightforward, just the hypotenuse of the triangle. D, to find that angle measure, we have to do arctangent of c over b. It has to be c over b, not to be over c. So let's talk about that. So c is in the numerator, which kind of makes sense to me because c goes with sine, which is kind of y, right? Y is in the numerator, x in the denominator. So arctangent c, b goes with cosine, which is like what would be x. So that's how I remember that c is always in the numerator, because c goes with sine, which is y. Okay, so that's just kind of a helpful thing. Now on quizzes and tests, I'm going to give you this portion. I'm going to write this portion out for you. Okay, so you don't have to memorize that part, but I am not going to give you these two pieces. You have to know these two pieces. Okay, now this is not going to be on tomorrow's quiz, but on the next quiz or test, it will be. So this part right here you would have to memorize, which really is not that bad, right? A is simply the hypotenuse of the the triangle, and D is just arctangent C over B. The Y, the sine, number in front of sine over number in front of cosine, which also tangent is sine over cosine, right? There's a lot of ways we could remember that it's C over B. Okay, so this part you're going to have to memorize. One little nuance that happens here is we have to pay attention to which quadrant we put angle D in. It matters. That probably is the portion of this lesson that might cause the most trouble for students, is if you get the angle in the wrong quadrant. So it depends on the signs of C and B. That's a B, and will be determined by sketching it. And I'm going to go through an example on how to, I have a couple examples actually, and I'm going to walk you through on how to decide what quadrant we need to put the angle in. Okay. All right. So questions about this content before I move to the examples? Okay, let's go to the second page. No. Only sine and cosine, that's right. Only sine and cosine. All right, so our first example, y equals 8 cosine theta plus 3 sine theta as a single cosine with phase displacement. Now typically it would tell you whether to put it in degrees or radians. I left this out, so of course I'm going to default to radians because why, I love radians. So but on the daily work there's some problems where we do degrees as well. Sorry, so let's I always start with drawing the triangle first. That's how I always start, because I don't want to put the angle in the wrong place. So how do we draw our triangle? This is significant. The way that we draw our triangle is by these two numbers. Okay, whatever those are. The number in front of cosine, the -8, is where we're going to move x, our x value. The number in front of the sine is where we're going to move for our y value. That's how we're going to determine what quadrant we're supposed to be in, by these two numbers. All right, so -8 is left, right? And 3 would be up, so we're going to be in quadrant 2. So I'm going to go ahead and draw my triangle here. So we have, what, a -8 and a 3. All right, so our A value that we need to find, I usually find that next since I'm working with the triangle anyway. The A value is just the hypotenuse of this triangle, right? It's just the square root of, so A is the square root of B squared plus C squared, so 9 plus 64. I mean, that's what A is just the hypotenuse, which would be the square root of what? Is that 73? Yeah, so A is the square root of 73. So now I know what A is. I know what quadrant I'm supposed to be in. Now let's work on finding our angle measure, D. So D is arctangent of, okay, we have to be sure to get these numbers in the proper order. In the previous class, a lot of students were mixing them up. So we need to be careful, cautious. So the one in the numerator is the one that goes with sine, right? That's the one in the numerator. So that's going to be the 3 over -8. Now this, of course, is not a unit circle value. We would have our calculator on a problem like this. So we put this in our calculator. And what our calculator is going to give us is -0.35877. 35877. Okay, so we stop and we think, okay, what quadrant is that in? Well, of course, it's going to be the principal value. Where would the principal value of arctangent be if the argument was negative? It's going to be in the 4th quadrant, right? It's going to be a backwards rotation to the 4th quadrant, because that's what our calculators only know. They only know principal values. All right, so this angle is in the 4th quadrant. That is not the quadrant that we need. Right, we need it to be in the 2nd quadrant. So, one way, well, to write a general solution, are you going to have to write a general solution? No, but I just think the more we see general solutions, perhaps the more comfortable, we come with general solutions. So this is a general solution. So our general solution would be negative 0.035877 plus pi n. Why pi? Because that would be the period of tangent, right? Would be pi. So in order to get an angle in the second quadrant, if I'm in the fourth quadrant, all I need to do is add pi, right? I just add pi to it. So I'm going to say negative 0.35877 plus pi. That's going to give us 2.7828. Okay, so D is going to be 2.7828. So let's just make sure. Sometimes we have a little bit of trouble determining what quadrant a radian is in because it's just weird numbers, right? I want you to think with me, if this is 0 radians and this is pi radians, right, all the way across, we know this would be 3.14. Right, if I go in this right all the way across, that'd be 3.14. This would be half of 3.14. Right, so I don't know, 1.8 or something. So 2.7 would definitely be between like 1.8 and 3.1. Right, so I know that is in the second quadrant. Okay, we okay with that? So now I'm just ready to write my answer. So my answer is going to be, I'll write it up here. So y equals our a, which is root 73. So root 73, then cosine of, now they're using theta as the variable. We really need to match our prompt. If our prompt is using theta, we should use theta. If our prompt is using radians, we should use radians. You know, if our prompt is using DMS, we should use DMS. We just need to match the prompt. So we match the prompt, theta minus 2.7828. And that is our very first problem. How are we on that? Is everybody okay? Okay. Let's look at our second one. So again, the very first thing that I'm going to do is I'm going to draw the triangle. Alright, so my x value is a positive 1 and my y value is a negative 1. Right? X is positive 1, y is negative 1. So my angle is going to be, my triangle is going to be in the fourth quadrant. X is 1, sine is negative 1. So then my a value is going to be the square root of 1 squared plus 1 squared, right? Or square root of 2. Okay, a value is pretty straightforward. Now we know we need a quadrant 4 angle. Alright, so now we're ready to work on our angles. So we would say D is going to be arctangent of, okay, the y one, the one with sine goes in the numerator, although they're both 1s, it doesn't really matter, right? But it would be negative 1 over 1. That is a unit circle value. We know arctangent is negative 1. The principal value is in the fourth quadrant, right? Negative 1, and it is negative pi over 4. Now, that is a fourth quadrant angle. I can use that fourth quadrant angle if I want to with a negative rotation, but I will tell you that many times, a lot of textbooks, okay, so I love textbooks. I love reading textbooks. I know that's very strange. Calculus books, like a whole stack of calculus books would be just like, oh, that would be like a party, right? Reading calculus books are my favorite. Precal's like my second favorite. But at any rate, many books use a positive rotation. I mean, they just change it to a positive rotation. Do we have to? No. You can leave it like that if you want to, but I'm going to change it to a positive rotation just so that we can see what that would look like. So if I wanted this to be a positive rotation, if I wanted to pick it up going around this way, I think we all know the unit circle well enough, right? That would be 7 pi over 4. So that's what I'm going to use. I'm going to use 7 pi over 4. So our answer would be y equals the square root of 2 cosine of theta, because that's in the prompt, minus 7 pi over 4. Now, what if I had wanted to use the pi over 4? How would that have affected this standard equation? It would have changed this, wouldn't it, right? It would have changed it to a plus. So you could say theta plus pi over 4. If you wanted to use the negative rotation, that's fine. I'm just demonstrating that mostly they use the positive rotation for whatever reason. Okay, but either is fine with me. All right, how are we doing on this lesson? Are we okay? Now let's say, I don't have a problem up here like this, but let's say that our arguments, let's say we have, for example, let's say 3 cosine 4 theta minus 2 cosine sine, minus 2 sine 4 theta. Okay, let's say, so first of all, if we have something like this, which you're going to, we have to verify, are the periods the same? And since they both have 4 theta, we would say yes. Right? They have to have the same period. These do. They have the same period. So how is that going to affect our answer if we have 4 theta in there? How is that going to affect our answer? Really, it would simply put a 4 here in front of the theta. Okay? That's all it would do. I mean, not for this particular one, but we would work this out, right? We would work it out. We would get y equals, a cosine, and then it would be 4 theta minus d, whatever our d was, right? So it just appears in the answer. There's nothing that we have to do to it. We don't have to divide it out or do anything crazy. We just have to verify that the periods are the same, and then our newly created function has to have that period. Notice how it's inside the parentheses. What if I wanted to graph that? Which of course you're going to have to do. What if I wanted to graph that? Could I graph it when it looks like that? We've talked about this before, right? Remember? Can I graph it when it looks like that? No. I'd have the right period, but I have the wrong phase shift, wouldn't I? I would have to factor out the 4 from both of these. So I'm just giving you a few little hints of other complications that you're going to come across. I think that pretty much gets most of the complications right there. Are we okay with that? Okay? All right, great.